Hello, ladies and gentlemen. My name is Franz Höpfinger. I talk today about the project logiBUS, or turning the ESP32 into a PLC with the FORTE IEC framework. Whenever you have questions, feel free to ask them in the Q&A box. We will start with an introduction. Then we will see the background of automation systems. Later, we will see how FORTE FORTE runs on the ESP32. We will have a look on special hardware. And then we will see application example as well as programming examples. Let's start with the introduction. My name is Franz Höpfinger. I'm a computer scientist. I work as a freelance software developer for HR Agrartechnik, HR Agrotechnik. This company was founded by Christoph Hante and Markus Rensing. Christoph Hante is also a farmer and an agricultural contractor. We will later see why this is important. And this company is mainly focused on ISOBUS control solutions like tire pressure control systems. Let's talk about the background of automation systems. We have always a technical process. So we want to produce some product. May it be material product like a car or immaterial product like a heated house. This process is sensed by sensors and is controlled by actuators. And these sensors are read in by a control systems, and the actuators are controlled by a control system. So a control system named a PLC, a programmable logic controller, you can say it's a small computer. And this will be programmed, configured, watched, and monitored by a PC. And nowadays, we also have the higher level and IoT connectivity like production control systems and so on. Let's talk about the motivation. We want to have a PLC on the ESP32. Hardware-wise, we found a lot of different boards and boxes for ESP32-based PLCs. They are sold everywhere, but programming-wise, most of them are programmed in C, C++, or in the Arduino IDE. There is no real function block-like programming environment. Talk about the hardware. There is really out a lot, like LilyGo. You see it on the left. This is LilyGo. Weidmuller, Seed Studio, and many, many more. There's a but. Most of them have not PSRAM on the ESP32 module. We will later see why this is important. And most have relays, not MOSFETs. If you are familiar with electricity, you know MOSFETs have a higher switching frequency and MOSFETs have less tear and wear. Now talk about the PLC environment. We have out in the market Codesys, we have Logicat, there is an open source one, the Open PLC project, and we have Eclipse for FORTE. There are many more, but these four, we had a closer look on it. So for Codesys, we found out it's not available on the ESP32. We asked them and they said, no, you must go full stack Linux, minimum a Raspberry Pi or higher. Logicat was willing to give us a free RTOS version, but it would be very costly. It would need a lot of porting to the ESP32 because running on free RTOS does not directly mean running on ESP32. And so, yeah, it would be possible, but we did not go that way. Then there is the Open PLC project. You will find this a lot in the internet. It has two big drawbacks. It is quite old. It's running on Python 2, not Python 3. You have problems if you want to install it on Linux. And it has no real monitor and watch. So this was really not the solution. And then we found Eclipse for Diag. It's open source, which is nice. And it has an initial ESP32 port available. It was a very basic port, but it was there and it was running. Now talk about PLCs. PLC is a programmable logic controller, as I already said. What we want a one-time flashing of a runtime. A runtime is a project, like you know it, the ESP-IDF project, which is compiled together and flashed on the normal way over the serial flasher. And then this runtime runs on the PLC. After this, you transfer the logic of the control over Ethernet or Wi-Fi, also over remote. So you don't need the serial connection. And then you can do monitor, watch, and force for variables and I/O. In a few seconds, I will explain what monitor and watch is. And also important, creation of a boot file. Now I took a line here. For us, it was also important to have ISOBUS support. For many people out there, especially if you are in the building or industrial automation, it will not be important for you. We wanted special functions for the agricultural market, compatibility to ISO 11783 ISOBUS, especially ISO 11783-6. It's a HMI solution for tractors and for agricultural. This said, it's clear we have one version which is good for PLC control, for building automation. This is fully open source, and we will have one version with ISOBUS. This is not fully open source because the ISOBUS library is not open source. So we have two versions, open source and open core. Next, talk about Eclipse for Diag. Eclipse for Diag is an open source project. It consists, as all PLC programming environments, of an IDE and a runtime environment, plus, of course, function block library and examples. So the main parts is the IDE and the runtime environment. Let's have a look on the IDE. If you're familiar with Eclipse, you will see that the menu bar, the symbols, the tree view, everything is same than the Eclipse IDE. Here we see the ECC, Execution Control Chart Editor. It's like a state machine, fully graphical programming, or Petrinet. Here we see a function block editor, a function block debugger, and here we see the connection of several function blocks together. We get improvements by time on the FORTE IEC, like recently we got the breadcrumb widget, we got the search box, we got the search result, we got the problems view, and so on. So Eclipse for Diag is developed actively. Next, we want to see monitor and watch. I already said this is one of the most important things on a PLC, to be able to load a model on the PLC, but also to monitor and watch the inputs and outputs of the function block. Here we see a typical situation. We see here this function block has an error, and he says in the status message, hey, I failed to register an observer. Also, force is an important function, so you can click on an input and you can override the variable during runtime. You don't need a JTAG connection to do this, but everything is done over Wi-Fi or Ethernet. Next, there comes a nice gag. UML diagrams are often written very nicely, but the code is written not in the same style, it's written ugly. FORTE avoids this. The model, the nice diagram, directly is executed on the controller. Now, an overview of FORTE. FORTE is the runtime system. It runs on many operating systems, Windows, which is not the most destination system because it has no IOs. POSIX systems like Cygwin and Linux. Linux is more important because embedded Linux is often used on embedded controllers. NetOS, ECOS, VxWorks, RCX, PikeOS, and FreeRTOS. This is the reason why we can run it on the ESP32. Here you see a lot of controllers it's running on, and here also are many controllers listed, like for example the Lego Mindstorm. In addition to that, we have a lot of communication interfaces, for example Ethernet PowerLink or OPC UA. And now this list is extended one point. We have FORTE also running on the ESP32. There are some requirements to take in account. The model, I think it's common to all PLC systems, the model is always in RAM. So if you have a bigger, larger program model, you need to have the PS RAM. So it runs on all ESP32 derivatives like the ESP32 S2, S3, C3, but it makes more sense to use the ones with PS RAM. Of course, you need Wi-Fi or Ethernet. Wi-Fi comes always with the ESP32. It can be station or access points. That does not matter. You just need an IP address. And we will use the file server for boot project and IOP loading. I will explain it on the next slide. This is the ESP32 file server. It's a standard one from the examples directory on GitHub. And here we can upload the IOP file, which is the ISOBUS object pool. It's a HMI definition. And here we can upload the fboot file. So after we finish development, we want the system to load the program at boot. And with the boot file, we tell them, hey, take this program and load it at boot. Don't wait for somebody who connects with the IDE. Now we want to see special hardware. We learned already in the beginning that there is a lot of hardware, but sometimes you need special. Special hardware mainly includes that we need a CAN bus usable as ISOBUS, and many of the off-the-shelf controller do not have a CAN bus. So one we developed is the Huginen moped. It's a German funny term. A moped is like a motorbike, and Hugine is a DIN rail. So it's a DIN rail solution. It's based on the M5 stack Atom PS RAM. Why PS RAM we explained already. It has 4 outputs. It's smart switch output, so MOSFETs, not relays, and it is 3 inputs. This is for some applications too less, the 3 inputs. So you can connect here 2 buttons, and then you have here 1 button on the M5 stack directly. So what's in production in the moment is a larger solution. I only have a picture of the PCB layout. They are not arrived, but in production. It's also a DIN rail solution. It's based on the ESP32 DevKit C, S2 or S3. You can plug it here. And it has 8 outputs. So here you see always a double output. And it has 8 inputs here. And it has also the CAN bus. I forgot to write it here, but you see here is the CAN bus connector. And it's in production now, so maybe later we will see the product. Then This is for education, for thin rail use and so on. We need also outdoor solutions, waterproof solutions. So we also have developed them as well. Here we have two derivatives. One is the dual out. You see here the same smart switch we saw earlier, two channels output, plus and minus for supply, and a CAN bus. So it's a two output controller with Wi-Fi and done. And if you need more than two outputs, yeah, we have a dual CAN version. You see here it has 0 outputs. It's as well waterproof. Here it has not the dual output, but this has a second CAN controller. And one CAN is for the ISOBUS and one CAN is for the internal bus. We will see it in the next slide. So the first CAN is the on-chip CAN of ESP32. We go to the ISOBUS. Here's the ISOBUS connector. And the second CAN is made with a MCP2518FD. You saw it in the picture here. And it goes to the I/O. So this is a 16 output module waterproof, and it has a CAN bus, so we can connect up to 16 of these boards. So we can have 16 by 16 I/Os waterproof, which is really a big machine you can control there. Yeah, and that's hardware solutions. For special hardware, of course, the FORTE IEC also can be adopted to all hardware solutions I mentioned in the beginning of this speech. Now let's look on some applications. We have made one open source application. So while the IDE is open source and the FORTE is open source, we also made an application open source, which you can load into your FORTE IEC IDE and use it as a template. So it's this slurry tanker in Austria, beautiful Austria, and it's fully controlled by an aux joystick and by a touchscreen here. The masks here, the graphical user interface is made with the Jetta ISO designer. This is a GitHub link where you can download this solution. This was a brand new tanker, so the farmer who was wanting this bought it without the control system and directly added this new control system on it. But this is not the only use case. We also can do retrofit to special applications. And now, hold on, it becomes very funny. This is an old controller. You see, it's still a PLC. It's a Klöckner-Möller Easy, very old, cabled, long cables, lots of wires, lots of connection terminals, and the operator's box is quite mechanical. So you see a lot of joysticks, lot of switches, lot of buttons. And so we switched it to a full touchscreen solution based on FORTE IEC and the ESP32. So it looks nowadays like this. It's much more beautiful. You have colors, which tells you which function is on and off. Instead, before you only had the switch position for on and off. And so it's much more modern. And on the tractor, it looks like this. So you have here your mapping, your tire control system, your speed, your RTK, and here you have the control of your slurry tanker. So beautiful solution, I would say. To have a comparison for everybody who is not familiar with tractors, here the driver had to look on this box. The box is also limiting the view outside the window, you can imagine. And also it's not so comfortable to grab always set high. And here he has all the functions on the joystick, so every touchscreen can be Every touchscreen button can be mapped on the joystick. He has it in a nice view, and the window is clear view. So I would say nice solution. If you have questions, feel free to enter it in the Q&A box. Now let's look some programming examples. We were asked by one customer, hey, I have also a joystick like this one, but this is a rocker joystick, so it has on-off switches. This joystick has analog axis, 2 analog axes, and he wanted to control a on-off output. Okay, we said that's quite difficult because to have a 0 to 100% axis to 2 outputs, you must do some calculation, and you also want avoid blinking. And we invented this dual hysteresis function block. And this dual hysteresis function block we can see in the next slide. Here we can see the interface of the function block. So you see already every input has a nice description. So the help, when you say so, is included already in the function block. And here you see the ECC, the execution control charge. So from the neutral position, it goes by input larger than mid position plus deadband plus hysteresis to the up position. It goes back if the input is smaller than mid plus dead to the neutral. And the same for down, but with minus. Mid position minus deadband minus hysteresis, down, and input larger than midband minus dead, go back to neutral again. And this can be directly loaded on the controller. No programming of C, C++, and so on. So really a nice model-based and function block-based development. As I said, if you have questions, feel free to enter them in the Q&A box. I will be available for questions after this speech. Thanks for watching. I hope you enjoyed it. Thank you.